On October 19, 2017, a telescope in Hawaii, operated by the Pan-STARRS project, detected an object unlike anything seen before in our solar system, named Oumuamua, Hawaiian for scout or messenger from afar arriving first. It was the first confirmed interstellar object to visit our cosmic neighborhood. Its discovery sent ripples through the astronomical community, sparking debates that ranged from scientific curiosity to speculative wonder. Was it a natural asteroid, a comet, or something far more extraordinary? Its elongated, cigar-shaped form, erratic tumbling motion, and unexplained acceleration defied conventional astrophysical models. Then, as quickly as it appeared, Oumuamua vanished beyond our observational reach, leaving behind more questions than answers. For years, it seemed like a fleeting cosmic encounter, a one-time visitor from the stars. But now, in a revelation that has stunned scientists and the public alike, Oumuamua has returned, and it's not alone. Accompanied by a group of enigmatic objects, its reappearance challenges everything we thought we knew about the universe. This is a story of cosmic mystery, scientific intrigue, and the tantalizing possibility that we are on the brink of a new era of discovery. Let's rewind to 2017. The discovery of Oumuamua was a historic moment for astronomy. Detected by the Panoramic Survey Telescope and Rapid Response System, Pan-STARRS, at the University of Hawaii, this object was unlike any asteroid or comet in our solar system. Measuring roughly 400 meters long and only about 40 meters wide, its elongated shape resembled a cosmic cigar or a flattened needle tumbling end over end. Its trajectory was hyperbolic, meaning it wasn't bound by the sun's gravity like planets or comets in our solar system. Instead, it was a visitor from interstellar space, passing through at a blistering speed of up to 196,000 miles per hour. Most perplexing was its acceleration. Oumuamua exhibited a slight but measurable boost in speed that couldn't be fully explained by gravitational forces alone, unlike comets, which often show similar non-gravitational acceleration due to outgassing, the release of gases as they heat up near the sun. Oumuamua had no visible coma or tail, features typically associated with such activity. Astronomers scrambled to study it, training every available telescope on the fleeting visitor. Theories abounded. Some proposed it was a fragment of a disrupted planet from another star system, ejected into the void millions of years ago. Others suggested it could be a hydrogen iceberg, with frozen gases vaporizing to produce the mysterious acceleration. A few bold voices, including Harvard astronomer Avi Loeb, speculated that Oumuamua might be artificial, a probe or relic from an advanced extraterrestrial civilization. The idea was controversial, but the object's peculiarities made it impossible to dismiss outright. By early 2018, Oumuamua had sped beyond the reach of our most powerful telescopes, exiting the solar system and leaving scientists with a tantalizing puzzle. It seemed like a once-in-a-lifetime event, a fleeting glimpse of the cosmos beyond our own star. That is, until now. Fast forward to July 2025. Observatories around the globe, including the James Webb Space Telescope and ground-based facilities like the Vera C. Rubin Observatory, detected an anomaly in the outer solar system, an object with the exact dimensions, tumbling motion, and spectral signature of Oumuamua was back, defying all expectations. Its return alone would have been astonishing, but what made this discovery truly jaw-dropping was that Oumuamua wasn't alone. Accompanying it were several other objects, each exhibiting similar characteristics: irregular shapes, erratic movements, and velocities that pushed the boundaries of known astrophysics. These companions weren't mere debris or fragments, as one might expect from a shattered asteroid. Instead, their movements appeared coordinated, almost purposeful, as if governed by an unseen force or intelligence. Renowned astrophysicist Neil deGrasse Tyson, known for his ability to communicate complex science with clarity and enthusiasm, brought this revelation to the public's attention. In a series of interviews and public statements, Tyson emphasized the unprecedented nature of this event. "This isn't just a scientific curiosity," he said. "It's a moment that forces us to rethink our place in the universe. These objects are behaving in ways we can't fully explain, and their return challenges the very laws of physics as we understand them." His words carried weight, not only because of his expertise, but also because of his reputation for grounded, evidence-based commentary. Tyson wasn't speculating about alien invasions or science fiction fantasies. He was highlighting a genuine mystery that demands rigorous investigation. The return of Oumuamua and its companions raises profound questions. How could an object that left our solar system return so quickly, within less than a decade? What are these accompanying objects, and why do they move in such a synchronized manner? bizarre? Are we witnessing a natural phenomenon, or could this be evidence of something far more extraordinary? Perhaps the first tangible hint of intelligent life beyond Earth? As observatories worldwide pivot to track these visitors, the scientific community is buzzing with excitement, curiosity, and a touch of unease. This is no ordinary cosmic event. It's a moment that could redefine humanity's understanding of the universe. The return of Oumuamua is not just surprising, it's perplexing. When it was first observed in 2017, its trajectory suggested it would continue into interstellar space, never to return. For an object to re-enter our solar system, it would need to lose energy or be redirected by forces external to our sun's gravity. Yet no known celestial bodies, planets, stars, or rogue objects could have provided the gravitational slingshot necessary for such a maneuver. The laws of orbital mechanics, as we understand them, simply don't allow for an object to reverse course in such a short time frame without some external influence. And yet, here it is, unmistakably the same object with its characteristic elongated shape and tumbling motion. What's more, the accompanying objects add another layer of complexity. These bodies, ranging in size from a few dozen to several hundred meters, don't behave like typical asteroids or comets. Their movements are not random or chaotic, as one might expect from a debris field. Instead, they exhibit a kind of synchronized choreography, spiraling or oscillating around a central trajectory, occasionally drifting closer to Oumuamua before resuming wider orbits. Advanced tracking algorithms have revealed patterns in their motion, rotational ellipses, phased formations, and orbit-like spirals that suggest a deliberate spatial configuration. This isn't the haphazard drift of natural objects, it's a dance of precision, as if the objects are communicating or responding to an unseen guiding force. The original mystery of Oumuamua's non-gravitational acceleration remains unsolved. In 2017, scientists proposed theories like outgassing, radiation pressure from sunlight, or even exotic materials to explain its behavior. None fully accounted for its sharp deviation from expected trajectories. Now, with its return, the puzzle deepens. The accompanying objects also show signs of non-gravitational acceleration, moving at speeds and in patterns that defy conventional astrophysics. Some researchers have noted that their surfaces reflect light differently than typical asteroids or comets, suggesting materials that could be engineered or shaped for purposes beyond passive movement. Could these objects be manipulating their environment in ways we don't yet understand? Are they harnessing solar energy, bending space-time, or employing propulsion systems beyond our technological grasp? One of the most striking aspects of this phenomenon is the coordinated behavior of the accompanying objects. Unlike a debris field, where fragments would scatter chaotically, these bodies move with a precision that borders on the uncanny. Observational data from telescopes like the James Webb and the Atacama Large Millimeter Submillimeter Array, ALMA, show that the objects adjust their relative distances and speeds with impeccable timing. Their formations resemble geometric patterns, spirals, ellipses, and phased alignments that maintain stability over time. This symmetry isn't just aesthetically pleasing, it hints at a structural system at work, possibly governed by principles of physics or technology we have yet to discover. Some researchers speculate that the objects might be part of a collective propulsion framework, communicating their positions through an undetectable medium, perhaps a field effect, resonant vibration, or even quantum entanglement. The absence of detectable electromagnetic signals, such as radio waves or light pulses, only deepens the mystery. If these objects are communicating, they're doing so in a way that's invisible to our current instruments. This silence is both eerie and profound, suggesting that we may be observing a technology or natural phenomenon far beyond our comprehension. At the center of this cosmic ballet is Oumuamua itself, which appears to serve as an anchor or nucleus for the group. While it hasn't altered its tumbling rotation or decelerated, its position within the formation suggests a pivotal role. Is it a leader, a beacon, or simply the first of many such objects we've detected? The idea that Oumuamua might be a scout or probe, as initially proposed by Loeb, gains new weight in light of its companions. If these objects are linked, whether by physics or design, Oumuamua may be the key to unlocking a larger network of interstellar phenomena. The scientific community is responding to this event with unprecedented urgency. Collaborative projects are springing up worldwide, pooling data from observatories, space telescopes, and computational models to analyze the visitor's behavior. The James Webb Space Telescope, with its unparalleled ability to capture infrared light, is providing detailed spectra of the object's surfaces, revealing compositions that don't match known asteroids or comets. Ground-based observatories, such as the European Southern Observatory's Very Large Telescope, are mapping their trajectories with pinpoint accuracy, while supercomputers run simulations to test theories about their propulsion and origins. One emerging field of study is the possibility that these objects are manipulating spacetime itself. High-precision measurements have detected subtle disruptions in the local spacetime curvature around the objects, distinct from the gravitational lensing effects seen around massive bodies like stars or black holes. These anomalies suggest that the objects may be employing exotic physics, perhaps negative energy density or spacetime compression, to move through space. If confirmed, this would represent a paradigm shift in our understanding of interstellar travel, suggesting that advanced civilizations might navigate not by brute force propulsion, but by altering the fabric of reality itself. Another intriguing hypothesis is that the objects are responding to the gravitational and magnetic fields of our solar system. Since their arrival, some have subtly altered their trajectories in tandem with Jupiter's movement, as if registering its massive gravitational well or magnetosphere. These adjustments suggest a form of predictive navigation, as if the objects are actively studying or mapping the solar system's dynamics. Could they be probes conducting a cosmic survey, collecting data on planetary alignments, magnetic fields, or solar emissions? If so, their purpose remains tantalizingly unclear. Perhaps the most unsettling aspect of this phenomenon is the object's silence. Despite extensive efforts to communicate with them, using everything from narrowband radio pulses to complex mathematical sequences, no response has been detected. This lack of communication doesn't necessarily mean the objects are lifeless or unintelligent. It could indicate that they operate on a medium we can't yet detect, perhaps neutrinos, quantum fields, or hyperdimensional signals. Alternatively, their silence might be intentional, a form of cosmic etiquette that avoids interference with a developing civilization like ours. This aloofness raises profound questions about their purpose. Why have they returned, and why now? Are they observing Earth, or is our planet merely a footnote in a larger cosmic agenda? The fact that none of the objects have altered their course toward Earth suggests that our world isn't their primary focus. Instead, they seem more interested in the outer solar system, skimming the heliopause, interacting with Jupiter's gravitational field, or calibrating their positions relative to the sun. This detachment is both humbling and intriguing, reminding us that the universe doesn't revolve around humanity. Some theorists propose that the objects are part of a long-term observational network, akin to cosmic time capsules or automated probes designed to monitor planetary systems over millennia. They might be collecting data on gravitational fluctuations, stellar evolution, or even the development of life across the galaxy. If so, Earth could be one of many data points in a vast interstellar archive, a node in a network we're only beginning to perceive. Alternatively, their behavior could indicate a calibration event where the objects revisit specific locations to verify cosmic measurements or recalibrate their instruments. This idea aligns with their synchronized movements and precise adjustments, suggesting a purpose that transcends mere exploration. The return of Oumuamua and its companions isn't just a scientific event, it's a cultural and philosophical turning point. Humanity has long looked to the stars with a mix of awe and yearning, wondering if we're alone in the universe. Now, faced with tangible evidence of interstellar visitors, we're forced to confront that question in a new light. The possibility that these objects are artificial, or at least governed by principles we don't yet understand, challenges our assumptions about our place in the cosmos. Are we the only intelligent beings, or are we part of a larger galactic community observed silently by entities far beyond our technological reach? This event has also sparked a renaissance of interdisciplinary inquiry. Anthropologists and historians are revisiting ancient myths and artifacts, noting similarities between the object's geometric formations and depictions in cave paintings, stone carvings, and stellar glyphs from cultures around the world. From the Andes to the Altai Mountains, stories of sky serpents or celestial messengers take on new significance. Could these be records of earlier visitations, encoded in the oral traditions and art of ancient civilizations? While speculative, this fusion of archaeology and astrophysics is opening new avenues of research, blending science with humanity's oldest stories. In popular culture, the return of Oumuamua is igniting imaginations. Artists, writers, and filmmakers are crafting new narratives inspired by the mystery, exploring themes of cosmic connection, exploration, and the unknown. Educational platforms are adapting curricula to teach students about interstellar phenomena, fostering a new generation of scientists and thinkers eager to unravel the universe's secrets. The event is a reminder that discovery isn't just about what we can touch or measure. It's about the questions that push us to dream bigger, to imagine possibilities beyond our current understanding. The question on everyone's mind is unavoidable. Could these objects be evidence of intelligent life? The idea, once confined to the fringes of scientific discourse, is now being taken seriously by mainstream researchers. The object's coordinated movements, non-gravitational acceleration, and unusual surface properties don't align with known natural phenomena. While it's possible they represent a previously unknown class of interstellar bodies, the alternative, that they are artificial constructs, can't be dismissed. If these objects are indeed probes or relics from an advanced civilization, the implications are staggering. They would suggest that intelligent life not only exists elsewhere in the universe, but is capable of traversing interstellar distances and revisiting our solar system with purpose. Their silence could be a deliberate choice, a form of non-interference that respects the development of younger civilizations like ours. Alternatively, they might operate on a timescale so vast that human history is a mere blip, their visits part of a millennia-long survey of the galaxy. The behavior of one companion object, which broke formation and accelerated smoothly toward the heliopause, adds fuel to this speculation. Its maneuver was precise, avoiding gravitational interference and aligning with the solar ecliptic plane before veering off at a sharp angle. This wasn't the chaotic drift of a natural object, it was a controlled, deliberate act, suggesting autonomy or pre-programmed intent. Some researchers have dubbed it a shepherd probe, guiding the others along a cosmic route or recalibrating their formation for a larger purpose. If true, this could indicate a network of such objects, operating across the galaxy in ways we can only begin to imagine. As we speak, the global scientific community is mobilizing to study these visitors. Telescopes like the James Webb, Hubble, and ALMA are working in tandem with ground-based observatories to collect data on their composition, movement, and behavior. Computational models are simulating possible propulsion systems, from exotic matter to space-time manipulation, while interdisciplinary teams explore the cultural and philosophical implications. Governments and space agencies, including NASA and the European Space Agency, are likely redirecting resources to track the objects, with some speculation that classified sensors originally designed for missile defense are now monitoring their movements. The coming months will be critical. Will the objects remain in our solar system, orbiting like artificial moons, or are they transients, preparing to vanish once more into the cosmic void? If they leave, will they return again, perhaps with more companions? The possibility that this is just the beginning of a cycle of visitations raises the stakes for humanity's observational capabilities. New telescopes, like the upcoming Square Kilometer Array, promise to enhance our ability to detect and analyze such phenomena, potentially revealing more interstellar visitors lurking beyond our current reach. The return of Oumuamua and its companions is more than a scientific anomaly. It's a moment of cosmic humility. For centuries, humanity has gazed at the stars, wondering if we're alone. Now, confronted with objects that defy our understanding, we're reminded of how little we truly know. Whether these visitors are natural or artificial, they challenge our assumptions about the universe and our place within it. They are a mirror, reflecting our curiosity, our ingenuity, and our infinite capacity for wonder. As we watch these silent travelers trace their arcs through the black canvas of space, we're invited to ask the big questions. Who sent them? Why are they here? What do they know of us? Their presence, precise and purposeful, speaks volumes without a single word. They are not invaders or emissaries of doom, but explorers, observers, or perhaps relics of a civilization long gone. Whatever they are, they've opened a doorway in the sky, one that humanity can never again ignore. This is a turning point, a moment that will be studied for generations. It's a reminder that the universe is vast, strange, and full of wonders we've yet to comprehend. As we continue to observe, analyze, and dream, we move closer to understanding our place in the cosmic tapestry. The return of Oumuamua and its companions isn't just a chapter in the story of science. It's the beginning of a new book, one that humanity will write together as we reach for the stars. The return of Oumuamua and its enigmatic companions has prompted a fascinating intersection of astronomy and anthropology as researchers uncover potential echoes of these visitors in humanity's ancient past. Scholars are revisiting archaeological records, from Mesopotamian cuneiform tablets to Aboriginal Australian rock art, noting recurring motifs of elongated, tumbling objects accompanied by smaller bodies and precise formations. These depictions, once dismissed as mythological or symbolic, now raise the tantalizing possibility that similar interstellar visitors may have crossed our skies thousands of years ago. For instance, Sumerian texts describe skyboats moving in synchronized patterns, while indigenous star stories from the Pacific speak of wandering stars that appeared and vanished unpredictably. If these are not mere coincidences, they suggest that Oumuamua's journey may be part of a cyclical phenomenon, with Earth serving as a periodic checkpoint in a cosmic itinerary spanning millennia. This convergence of ancient wisdom and modern science invites us to reconsider humanity's history, not as isolated, but as potentially intertwined with a broader galactic narrative where our ancestors may have witnessed the same silent travelers we observe today. The object's behavior, particularly their apparent ability to defy gravitational constraints, has sparked a surge of interest in theoretical physics and engineering. Scientists are exploring whether these visitors could be utilizing advanced propulsion systems, such as Alcubierre-like warp drives or electromagnetic field manipulation, concepts once relegated to science fiction. The observed disruptions in local space-time curvature around the objects suggest they might be bending the fabric of space itself, compressing distances rather than traversing them conventionally. This has led to a flurry of new research proposals, with institutions like CERN and MIT launching initiatives to model hypothetical technologies that could replicate such effects. If these objects are indeed artificial, they could represent a technological leap so profound that it forces a reevaluation of our understanding of energy, matter, and the fundamental structure of the universe. The prospect of reverse engineering even a fraction of their mechanics could propel humanity into a new era of space exploration, where interstellar travel becomes not a distant dream, but a tangible goal. Beyond the scientific and cultural implications, the presence of these objects raises profound ethical and existential questions. If they are artificial, what are the responsibilities of humanity in responding to their presence? Should we attempt active communication, risking exposure, or maintain passive observation to avoid unintended consequences? The lack of direct engagement from the objects suggests a principle of non-interference, prompting debates among ethicists about whether humanity should adopt a similar stance. Philosophers are grappling with the implications for human identity. If we are not alone, how does this redefine our sense of purpose, our religions, and our place in the cosmic order? These questions are not abstract. They are shaping policy discussions in international forums, where world leaders are beginning to consider protocols for potential interstellar contact. The return of Oumuamua and its companions is not just a scientific milestone, it's a catalyst for humanity to confront its readiness for a universe that may be far more populated and complex than we ever imagined. The synchronized movements of Oumuamua and its companions have led some scientists to propose that these objects may be part of a vast galactic network, a system of interconnected probes or beacons designed to monitor or map the cosmos. This hypothesis suggests that our solar system is merely one of countless nodes in an interstellar grid, with these objects serving as automated sentinels that collect data over eons. Their precise formations and non-gravitational maneuvers could indicate a sophisticated navigation system, possibly guided by gravitational gradients or cosmic currents invisible to our current technology. If true, this network might be collecting information on stellar evolution, planetary dynamics, or even the emergence of life, with Earth as a minor but intriguing data point. The idea of a galactic infrastructure challenges the notion of space as a chaotic void, replacing it with a vision of an ordered cosmos, where pathways and junctions facilitate efficient transit across unimaginable distances. Such a discovery would not only reshape our understanding of the universe, but also prompt humanity to consider its role within a larger interconnected galactic community. The return of these interstellar visitors has sparked an unprecedented level of global scientific collaboration, transcending national boundaries and institutional rivalries. Research teams from NASA, the European Space Agency, China's National Space Science Center, and private organizations like the Breakthrough Initiatives are pooling resources to analyze the object's behavior, composition, and potential origins. Data sharing agreements have been fast-tracked, with observatories in Chile, Australia, and South Africa coordinating observations to ensure ensure continuous coverage. This collective effort extends beyond astronomy, involving experts in artificial intelligence, quantum physics, and even linguistics, as researchers explore possible communication methods. The urgency of this event has also prompted funding agencies to prioritize interstellar research, with grants supporting the development of next-generation telescopes and computational models. This global unity reflects a shared recognition that the implications of Oumuamua's return extend beyond science, touching on humanity's collective future and our place in the cosmos. The presence of these mysterious objects is not only a scientific and technological challenge, but also a profound psychological awakening for humanity. The realization that we may be observed by entities, whether natural or artificial, has ignited a global conversation about our species' identity and aspirations. Social media platforms are abuzz with discussions ranging from awe-inspired wonder to cautious speculation about the implications of contact. Psychologists note that this event is reshaping humanity's collective psyche, rekindling a sense of curiosity and humility reminiscent of the Apollo era. Educational institutions are reporting increased enrollment in STEM programs, as young people are inspired to explore the mysteries of the universe. Meanwhile, spiritual and philosophical communities are grappling with the possibility that our existence is part of a larger cosmic tapestry, prompting introspection about meaning and purpose. This psychological shift is a testament to the power of Oumuamua's return to unite humanity in a shared quest for understanding, reminding us that our greatest discoveries often begin with a single humbling question: what else is out there?